Hello again, Einstein. Welcome back to Part C of Basic Math Stuff. In this instruction unit, we're going to review addition, subtraction, multiplication, division, and quickly exponents. But let's begin with addition and subtraction. A positive number is written without the plus sign. So for example, 5 equals really plus 5. If I'm subtracting a positive, that is the same as subtraction. Or if I'm adding a negative number, that's also the same as subtraction. And examples might be 5 minus plus 3, that equals just 2. This example would be 5 plus negative 3, also 2. In other words, you can think of subtraction as adding the opposite. Subtracting a negative is the same as adding. In this case, it would be 5 minus 3 is the same as our first case of plus 5 plus 3. That would be 5 plus 3, and that equals 8. The two negatives become a positive. And conceptually, you can think of that. If I say, I'm going to go, that's positive. If I said, I'm not going to go, that's negative. But if I said, I'm not going to go, that in turn would be positive again. So two negatives make an addition. How about multiplication and division? Multiplication is really addition in the sense that 2 plus 2 plus 2 added 3 different times is the same as 3 times 2. In the case of a positive times a positive, the result is just positive. 2 times 3 equals plus 6. A positive times a negative, however, or a negative times a positive, is essentially the same result, and that's a negative. In this case, 2 times negative 3 equals negative 6. Another way you could think of it back in our connection to addition here is 2 times negative 3 is essentially minus 3 plus minus 3, which is minus 6. The order doesn't matter. It could be negative 2 times 3 still equals negative 6. And a negative times a negative equals a positive on multiplication. Minus 2 times minus 3 equals plus 6. So like addition or subtraction, two negatives make positive, or the operation of positive. In this case, multiplying by two negatives essentially cancel and make a positive. So how does that work in the case of more than just two numbers? Subtracting a negative of a negative is essentially just subtracting a number. So for example, let's plug in a number. If I have 5 minus opposite of opposite 3, the opposite of opposite 3 is plus 3. So that really becomes 5 minus plus 3, or 2. It's just subtraction. How about in the case of multiplication of 3 negatives in this case? A negative times a negative times a negative. Or let's put numbers to that. Minus 3 times minus 3 times minus 4. Minus 3 times minus 4, as we saw before, is two negatives that become a positive, positive 12. And we're multiplying that in turn by minus 3, so that really becomes negative 36. So the 3 negatives, we know 2 of them cancel to become a positive, leaving 1 negative, which remains for a resulting value, negative 36. Division is when you take a number and you do the opposite of multiplication. It could be 6 divided by 3, for example, which can also be written as 6 divided by 3 equals 2. We know one thing. Division is the same as multiplying by the reciprocal. and the reciprocal is 1 over the number. So 6 divided by 3 really equals 6 times the reciprocal of 3, which is 1/3, and that, of course, in turn equals 2. So division is really just multiplying by the reciprocal of the number you want to multiply by. Summarizing what we just learned, we saw how the interchange of signs works in addition, subtraction, and multiplication division. For example, subtracting a positive number, as we normally think of subtraction, really is the same as adding a negative number. And subtracting a negative number is the same as adding. And very similar to that, multiplying a positive and a negative, or a negative and positive, results in a negative number. Multiplying two negative numbers together results in a positive number. Conceptually speaking, each of these operations can be expressed as a function of each other. As we saw, subtraction really is addition of negative sign numbers, and multiplication really is the same as adding a number together that many times. And last but not least, we saw division is the same as multiplying by the reciprocal of a number. And real quick, we can visit exponents, or squaring a number, for starters. If I were to square a number, say 3 squared, that is essentially the same as multiplying that base figure 2 times. 3 times 3. In other words, the number of exponent times. Likewise, if it were 3 to the 4th, that would be the same as 3 times 3 times 3 times 3 4 times. So we can think of squares as a special case of exponents where the exponent equals 2, and exponents as really essentially just multiplication, saying multiply that base value by the exponent number of times. And that wraps up Part C of basic math stuff. Part D will look into the order in which we do all these various operations, as well as the associative, commutative, and distributive properties for these operations, and why they're actually important.